Hello, welcome back to another video. In this video, we'll be taking a look at k-fold cross-validation and how we can use k-fold cross-validation to essentially improve the accuracy score of our model. Now, in our previous videos, we've been taking a look at a model called the train test split method. And the train test split method uses the data set and it divides the data set into the training and testing set, where we specify some test size, such as in this example, we specify 30%. So it means that we are dividing our data set in a way where 30% of this of the data will be used for validating our model. How well it performed, and the 70% of our model will be used. The 70% of our data set will be used to train our model. Now, what are the problems that are involved in train test split methods? First of all, the training set might contain some repeated records, so we might miss out on some of the important examples, and we might. So if our data set contains some repeated records, our model really doesn't learn something new, and it keeps on repeating on the same examples. And this is one of the problems in train test split function, because we're not able to shuffle our data set very well in the train test split function. And then we have another problem, which is that our model might miss out on some parts of the data. So there might be some classes, or if you're talking about the classification task, we might miss out on some categories or classes that our model had to predict, but it was never able to see those parts of the data. And then the final one is that since we're using some ratio to split our data set, we might get less data for our model to train on, and that's exactly why we are very likely to get a lesser accuracy score of our model using the train test split function. Now, how does the k-fold cross-validation work? So you have a data set, and the general idea is to split your data set into k number of folds. So if you have some value of k, you split your data set into k number of folds, and then further use one of the folds for the validation, and the rest of the folds for training the model on. Now, imagine an example where you have k, the value of k equals 4. So you divide your data set into 4 folds, and then for each fold, for each iteration, you will have one validation. You'll have one validation fold, and the rest of the folds will be used for the training, and then you will keep going on until you are able to iterate every single part of the folds, and then you get scores for each and every one of the validation sets. Now, what you do is you try to actually average out these scores, and what you get is the average score for the k-fold cross-validation. Now, this can be used to determine how well our model did on the whole data set. Now, this was the basic idea behind k-fold cross-validation, and now we'll be taking a look at how we can implement this in Python. Alright, so now we're going to be implementing k-fold cross-validation, and I've opened up my Jupyter Notebook environment here, as we're going to be implementing this in Python. And so the dataset I will be using for this video is called the Titanic dataset. And if you just try to actually go ahead and load this dataset into our environment where they have a pandas, let's just try to do that first of all. Okay, so I'll say import pandas as PD, and I'll just go ahead and first of all run that. I'll say data set equals PD dot read, and as you can see, this data set right here is not a CSV file, it's an XLSX file, and the way you read XLSX files in pandas is by using the Excel function, right? So it's called the read Excel function, and what you do is you just pass in the Titanic, you just pass in the file name or simply the file path here, and then just like that, XLXX. Okay, there, yeah, oh come on. So then we'll just go ahead and try to get an idea what dataset looks like. Okay, alright, so you can see that this dataset, this is what this looks like, and this dataset contains a lot of columns, as you can see. This has the columns that we are really interested in this particular dataset are this one right here, which is going to be the label column. You can see these are the values that we want to predict based on the attributes available here, right? And you can see the attributes are there are a lot of attributes. So what I will do is I will just try to print out the first few rows so that we don't create a lot of mess. And yeah, so you can see so we have embark, cabin. Some of these some of these columns we will not be using these columns, right? We won't be using every single one of them. We will be using very few of them. Okay, so I'll just go ahead and try to reduce the name of the try to actually make this a little bit shorter name, because we'll be using this name for a while in our next few lines of code. So now what we'll do is we'll just go ahead and print out. Okay, perfect. So now we have loaded our data set. So let's just go ahead and try to apply some pre-processing before we feed it into our model. Okay, so let's just try to first of all convert this into let's just pick some of the columns that we really need from this, right? We don't want all of them, so I will just specify some of the columns that I need from this data set. So data set equals pd dot data frame, and then what I will do is for the data I'll pick everything inside this data right here, and for the columns I'll pick some of them, which is number one, the passenger class. We might need that one, and I'll actually explain why I'm picking these attributes. Okay, we also need the age, we need the sibling specification, and then we also need the parts, we need, yeah, we also need the embarked, and then finally the last one that we need is the survived column, because we obviously be using this one to predict, right? So if we just do that, we have now we now have a data set. So now what I will do is I'll just go ahead and show you what we have. Okay, so if I just run, you can see now we have all the columns, and you can see it has we have actually ignored a lot of, so we have ignored the name, we have also ignored the ticket columns, and the reason for that is that because we will not be able, it's not easy to process these things, and obviously since I just want to predict whether a person survived or not, so it has nothing to do with the name of the person, right? And you can kind of think of this as logically, that the name of the person is not, doesn't really matter in terms of the, in the fact that whether the person survived or not. But yes, many of the other attributes, such as the class of the passenger, or maybe if the passenger was male or female, or what's the age of the passenger, that might contribute to the fact that whether the passenger survived, right? So yeah, I'm really sorry if I was not able to explain the dataset at first, but yeah, this is what this dataset is all about. We want to find out which passenger survived and which passenger was not able to survive based on the given attributes, right? Alright, so we have now picked our columns, and you can see that some of the columns here do not need a lot of pre-processing, and some of them do, right? So if we have this gender column, which seems to be in string, and we need to somehow convert these values into numeric values, right? Because these are categorical values, but we need to convert these categorical values into numeric values. Obviously, they will still be categorical, because we can because this is like a binary column where it could be either male or female. So we'll be having we need to encode this column, and then another column that we have here is the embark column, where it has some categories such as a Q, S, and C. We need to encode them too. And then you can also see that we have some of the NaN values in our data set, so we want to remove them as well. Okay, so what I'll do here is I will actually go ahead and import a few things, because we need to actually go ahead and apply the pre-processing of this data. So what I will do is I will import from scikit-learn dot pre-processing import, and what I will import here is called the label encoder. Okay, there it is. So I'll just go ahead and save that, and now let's just try to actually go ahead and first of all drop all the NaN values. So what I will do is I will just go ahead and just remove all the NaN values, and the way we do that, we just go ahead and say dataset dot drop NA, and if I just run that, you can see now our dataset does not have any NaN values, right? Awesome. So that's done. We know we have NaN values. Now we also need to encode some of the columns. Okay, so the way we encode the columns is we use the label encoder, and what I will do is I will first of all create I will initialize the label encoder here, which is label encoder, and now then what we will do is we will actually go ahead and wait a second. I think yeah, good. Alright, so what I will do is I will first of all just try to um just first of all I will just go ahead and use I will just try to, I don't know, maybe I'm making a mistake here. Maybe I need to maybe I need to assign the data set that has no NaN value into a new data set, and that's going to update our data set, right? So that's what I want to do. Okay, good. So I think that should just not end up this will not end us on any sort of error. Okay, so now what I will do is I will actually go ahead and apply. So the columns that we need to apply the label encoder is the gender column and the embark column, right? And the rest of the columns do not need anything else. All right, great. So what I will do is I will just go ahead and say data set, okay, and the column we need is the gender column. So I'll use that gender column, and then we need to remove, we need to encode the values, right? So the way we do that, we say le dot, so le is the alias for the label encoder here, and what I will do is I will say le dot fit underscore transform, all right, and then in the data I will just pass in my data set, all right, and then I'll just go ahead and pass in the same column. So what it will do is it will actually go ahead and encode all the values in that column, and then it's going to update that column in the main data set. Okay, perfect. And then we will do the same for the embark column, right? So I'll just go ahead and paste that here too, and I'll just go ahead and say embarked, good, and then we'll do the same thing for here for this one, embark, and yeah. So now I think that's good. So now we'll just go ahead and print this out and see what happened. So you can see now we have encoded all the values in the gender column, and the similar, and we've done the same for embark. So you can see we have all the values 0, 1, and 2 for embark, and then we have gender f1 for male and 0 for female. Great. So that's what we needed, right? So this is basically what we can feed into our model. Good. So I think we are good to go with our pre-processing. So we'll just go ahead and divide our data set into label, the feature and label set, right? So I'll just go ahead and put all the features into my X, and I'll put the label into Y, and then what I will do is I will just go ahead and say data set, right, and data set dot iloc, and then iloc is basically used for slicing the data frames in pandas. Okay, so what I will do is I will pick all the columns, all right, and then we want to pick all the rows, and then here the columns that I want to pick are going to be going to start from 0, 1, 2, 3, 4, 5, 6, 7. So we don't want to include this one, so right, so I'll just go ahead and type 7. So what it will do is it will start from 0 and go all the way to 6, right? Because the way it works here is that 0 is the inclusive value, and the 7 is the exclusive index, right? So it's not going to include the last column, right? Okay, so with that being done, we also need to actually we also need to save the last column into this y variable. So what I will do is I will just use the last column here. So I will use all the rows at the last column, which is 7. Okay, so with that being done, if we just do that now, okay, so we have errors. It says it's an invalid key. What does that really mean? Oh, okay. So we need to use the iloc here too. And if you run that, perfect. So we don't have any error. So we just run this now. You can see that the survived column is not here, but when you print out the y, we have the survived column, right? Awesome. So we're done with our we're done with the pre-processing of our data set, and now it's time to actually go ahead and create our model so that we can actually go ahead and train it on the data set that we have here, right? So what I will do is I will just go ahead and say from scikit-learn dot pre import decision tree classifier. Yeah, so that's what we needed, and we also need to actually go ahead and use one more thing, because we want to first see how our model does when we use the same old train test split technique, and then we will actually try to compare the accuracy with the k-fold cross validation. Okay, so what I will do is I will actually import the train test split function. So for that we'll just go ahead and say from scikit-learn dot model selection import train test split function, and then finally I'll say from scikit-learn. Okay, so I will just go ahead and import the k-fold cross validation later, but right now I just need to just import these things. Okay, perfect. So what I will do now, first of all, I will just try to split our data set into the training and testing sets so that we can actually go ahead and see how our model performs. So the variables that we need here are called xtrain, right, and then we have xtest, and similarly y train, and then we have y test, right? These are the four variables that our train test split function will return. And here I'll just pass in my x and y. We need to actually pass in our test size. That is going to be about 30%. We'll be taking the 30% of the data set into for the testing, and we were using the 70%, the rest 70% of our data set for the training. Okay, so this is a pretty simple technique that most of us use for training the model, and this is a very common one, right? And this is exactly what we will be using to compare our k-fold cross-validation technique, which is going to actually improve the accuracy of our model. Okay, and you will see how like by how far it improved our model's accuracy. Okay, so the next thing that we need to do is we need to actually go ahead and create our model. So I'll just go ahead and say model equals decision tree classifier, and here I'll be using the cart algorithm, and the cart uses the Gini index, or the Gini as a formula for computing or classifying the attributes, right? So if you don't know what the Gini is and how this whole decision tree classifier works, I've actually made a very detailed video on how the decision tree works, a very step-by-step guide, and then I've also shown how to basically create a decision tree classifiers in Python. Right now, I will not be focusing on this classifier because our goal is to actually compute the accuracy, or we are targeting the k-fold cross-validation in this video. So I would highly encourage you to actually go back and watch that video of mine. It's going to actually go ahead and clear all the concepts related with decision trees. Alright, and this is exactly why I'm using the Gini index here, right? Okay, with our model being created, we can now run this. We can now run this cell, and now what we need to do is we need to fit our model with our training data set. So the function that we'll be using is called the fit function, and then I'll just pass in my x train and y train. Okay, and then I'll just run that. You can see it. Our model gets trained. Awesome. So now we need to compute the accuracy, right? So how do we compute the accuracy? We want to somehow we need to have a variable. So we already have a variable for the y test, which has the actual results, and we have the x test. So these are the values that the model has never seen. So what we usually do is we use the function called the accuracy score function, and I haven't actually imported that yet, so I'll just go ahead and import that now. So from scikit-learn dot metrics import accuracy score. Okay, this is the function that we need. Okay, and then we will just call in our so first of all we need to make predictions, right? So I will just go ahead and make a variable called y underscore predicted, and here what I will do, I will say model dot predict, and I'll pass in my x test here. Okay, so this is actually going to go ahead and create the predictions. Actually, it's going to make the predictions for us. So if you just take a look at this predicted column, you can see it has made the predictions as zeros and ones. Whether the person survived or not, and the actual results for the same rows are inside the y test column right here. And you can kind of get the idea why do we really do this, right? So now we can actually go ahead and compare these two to see how well our model did, right? So what I will do is I will just use the accuracy score function. So we can pass these two things in our accuracy score function. And what I will do is I will say accuracy score, and I'll pass both of these things inside the accuracy score function. And let's see how well. So you can see it instantly computes the score for us. And our model is 74% accurate given these test data sets, on these test data sets, which is a fairly good accuracy, but we can do better, right? And this is exactly why we will be using k-fold cross-validation in this video. Okay, so now actually let's move on to the k-fold cross-validation. Okay, so the way we have how we use k-fold cross-validation in scikit-learn is by using the function called the cross-val score, and it's a part of our model selection library. So I'll just go model selection class. So I'll just call that one scikit-learn model selection, and I'll just go ahead and say import cross-val score. So we'll use this one. There we go. So this is the function that we'll be using to compute the scores. And now, since I've already taught you how cross-validation works, we will basically be splitting our data set into k number of folds, and where k minus 1 folds will be used for the training, and the kth fold, or simply the one fold that we will be picking for the testing, will be used for the testing. Alright, So what I will do is I'll just go ahead and obtain all the scores for the folds in this train scores list here, and this list is going to be returned by our cross-val score function. And this function receives three things. All right. So the first thing that this function receives is the model that we have created above. This is the model, the decision tree, and then the second thing it receives, is the feature and the label set, and the third thing is the number of folds we need to split our data set into. Okay. So first of all, we pass in the feature set, which I will be passing in the training data set. You can obviously pass in the X right directly, but I just want to see how well it does. Okay, so I'll just use this one. All right. Then what I need to do is I need to just go ahead and say X train and Y train, and then we can now pass in. Okay, so first one more argument that we have here is called the accuracy, because we want to compute the accuracy for every single fold. And then how many folds do we need to split our data set into? So let's suppose I want to split our data set into 5 folds. Okay, and you can obviously choose any number of folds you want to, but since we don't have a very big data set, so I think 5 folds will be enough. All right, so then what I will do is I will just try to just run this one, and you can see it already. So what it did in behind the scenes, it basically took every single fold, it trained the model on every single fold, and then used the one fold that it was not used to train on, and it obtained a score and saved that score into the list, and it kept updating the list for all those 5 scores. So when I print the train scores here, you'll see the list of scores here. So you can see this is the list of scores, and you can see our model kind of did bad at one of the folds, and it kind of did quite good at one fold. As you can see, our model was able to reach 79% accuracy, which is a bit better compared to this one right here, right? And then so obviously we can obviously improve this k-fold cross validation by kind of changing the parameters or simply adjusting the values of these parameters, and this might even go better. Our model might do even better than this. Okay, so what I will do now is I will just go ahead and try to print the average score for this. So what I will do, since obviously we did not use the test data set for computing the accuracy, and this accuracy right here was for the test data set, right? And we can compare this accuracy score with this one right here, right? Because this one was basically based on the training data set. So we will use we'll use the test scores for this. All right, and the way we do that, we just use the test. I will create another list, and I will copy the same exact thing here. Copy and put an equals to here, paste it, and then I'll just change this one to test, right? And I'll change this one to test 2, and then let's see how well this did, right? So I'll just print this out, and okay, so the accuracy scores that we are getting for this one right here is 76%, and it's not really that good, but we can kind of change the number of folds of our model and see if it does a bit better. And you can see it does not really do a good job, so maybe if you could just change this to 10. We can try different things. Okay, so so you can see it was able to kind of get to 77% accuracy, which seems good, right? Which seems a bit better than this score right here. Obviously, we're not using a very good data set for testing our model on, right? So we can kind of use different techniques to somehow pre-process our data better, or maybe use maybe keep adjusting or keep changing or shuffling the parameters passed into this function, and you will see that the result is going to improve. Or maybe the model itself doesn't really can do a better job than this, right? So you can kind of get the idea that there are many factors affecting this, right? So what I will do is I'll just print the mean scores, and so you can see the mean score is actually lesser than the accuracy score that we had with the train test bit function, and that might be because of the factor that the average score was not good, right? So maybe if you could just change this to 5 folds and then print the mean score, it kind of improved. Okay, Okay, so this definitely did not do a very good job, and it definitely has to do with the decision tree itself. Maybe the decision tree needs more. Maybe the algorithm that we're using, this decision tree, needs more data to get better, right? And you can see that it was able to do a bit better job at the training set, where it was able to reach the 74% accuracy. So if you just print the same for the training scores, let's see what do we get for the training scores. So you can see this one actually reached 75% accuracy. So I will just try to change the folds here and see how it goes. So you can see it improved by 76%, and yeah, so you can see how we were able to make some of the improvements. But this is exactly why K4 cross validation is not the only technique that we use to improve to improve the accuracy of a model. And there are many other techniques, such as in symbol learning, where we try to apply bagging and boosting on a model that should improve the accuracy of a model. All right, so there are many factors that affect how our model is trained, essentially. Yeah, so that was it. I hope you learned something from this video, and if you did, don't forget to subscribe to my channel, because I'll be uploading more of the machine learning videos. And also comment down below if you have any queries related to this video, or if you what you really want to see in the next video. Okay, peace.